Picture this, a tree standing tall for decades, weathering storms and seasons, all while silently thriving in its ecosystem. But how does it do it? In today's episode, we are going to explore the incredible journey of a tree, revealing the unseen challenges it faces and the remarkable strategy it uses to survive. Curious about how nature works its way, let's get started. Let's dive into the solving the problem of a tree and the guesses about its edges step by step. Imagine we are sitting down together, maybe at a cafe, with a whiteboard in front of us, and we are sketching out the logic. First things first, we need to set the stage with our data structure. We have a tree represented as a graph. Since trees are made up of nodes connected by edges, we'll use a dictionary where each key is a node and the value is a list of its connected nodes. Next, we introduce a hash set called guess set. This will hold our guesses about which edges are correct. Think of it as a way to quickly check if a guess is valid or not without having to search through a list every time. Now, we also need a way to keep track of parent child relationship within the tree. This is where parent map comes in. Each node will point to its parent, and this becomes crucial when we start exploring the tree. Before we start processing our input, let's talk about the threshold for winning, which we'll call K. This is the minimum number of correct guesses needed for a win. And to track our successes, we have a win count that increments whenever we meet or exceeds this threshold. With our structures in place, we move on to reading our input. We'll begin grabbing the number of test cases. For each test case, we read the number of nodes, which tells us how many points our tree has. We initialize our tree structure here, preparing it to hold connections. Now comes the fun part, building the tree. We read the edges, which are pairs of nodes. For each pair, we'll add connections in both directions because our tree is unidirected. So if node U connects to node V, we add V to U's list and vice versa. Once our tree is built, we read the number of guesses and the threshold K. This is where we start thinking strategically. We will collect all the guesses in our guess set, ensuring that we can quickly reference them later. Now, let's talk about DFS or depth first search. To kick things off, we'll perform our initial depth DFS starting from the current node, which is usually node 1 in our case. During this traversal, we'll populate our parent map and also count how many of the guesses are correct. It's like a warm up. It prepares us for a real challenge ahead. And after we have our initial count of correct guesses, we are ready for the next level, the rerouting DFS. This is where the magic happens. We go through each node again, but this time we consider it as the root and explore how the correct guesses change. If the correct guess if the current guess matches our direction, we adjust our count accordingly. And if at any point during this rerouting our count of correct guesses meets or exceeds K, we increment our win count. This is how we tally our successes as we explore different branches of the tree. Finally, once we have rerouted to all nodes and counted our wins, we need to represent our result in the simplest form. We compute the greatest common divisor GCD of our win count and the number of nodes. This helps us reduce our fraction, giving us a clear answer. And that's our journey to a solution. We have structured our approach logically, capturing the essence of the problem while maintaining clarity. Alright, everyone, let's wrap up what we have covered today. We have tackled the fascinating problem from HackerRank called the story of a tree, where we built a tree structure from user input and analyzed guesses on paths between nodes. We went through the code step by step, starting from how to construct our graph using a dictionary and a list. Then we moved on to the DFS search method to establish parent-child relationship and count correct guesses. Finally, we implemented our rerouting DFS to evaluate all potential routes and calculated the winning guesses based on the threshold K. The key takeaway here is the clever use of DFS for establishing relationship within the tree and rerouting for comprehensive analysis. We also learned how to compare the greatest common divisor GCD to represent our final result in reduced fraction form. This not only deepens our understanding of pre-structured tree traversal algorithm, but also gives us practical experiences with data structures in C#. Make sure to check out the link in of the source code in the description below. If you have enjoyed this walkthrough and you want to see more coding challenges simplified in real time, don't forget to like this video and subscribe to our channel for future content. In our next episode, we'll be diving deeper into graph theory concepts and exploring breadth first search techniques. So stay tuned and keep coding.